Hello, and welcome to my Pre-Algebra Big Ideas review series. Today's video is Chapter 8, Section 3, titled Volumes of Spheres. By the end of this video, you'll be able to answer the question, how can you find the area of a sphere? You'll have reviewed recent lessons regarding finding the volume of a sphere and finding the radius of a sphere, and to include finding the volume of a composite solid. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It'll more than likely help them, and certainly will help this channel to be seen by more students. If you'd like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Okay, let's get doing some math. Okay, a key idea here, the volume of a sphere. In words, the volume of a sphere is the product, that's multiplying, right? The product of 4/3 and the cube of the radius of the sphere. In the past, we've always used the square of the radius, right? But now it's the cube of the radius. In algebra, it's right here. Here's the formula. The volume of the sphere, and I put this S on here because I like to clarifies that this is the volume of a sphere. It's not important, believe me, it's my own preference. 4/3 times the radius cubed. It's the radius times the radius times the radius. The cube of the radius of the sphere. That's the important piece here. And you can see it as just a regular, like a basketball or a baseball or whatever kind of ball you want. And the radius comes out from the center out to anywhere on the sphere. That's the radius. Okay, for example 1, finding the volume of a sphere. It says find the volume of the sphere. Round your answer to the nearest tenth. So what do we start with? As I like to always say, and I know you've heard me saying many times in the past if you've been following my channel, write the formula, write your equation, whatever the problem is, write it out, and then compare to make sure that what you're writing matches exactly what you're looking for. And then start from there. You sure would hate to have to solve a whole problem and then find out that you missed a negative sign or you multiplied when you should have divided or whatever the case is. So always first of all, write the formula. So here it is. The volume of a sphere is 4/3 pi r cubed. Remember the cubed. And then we take the information we know, we look at the problem, we look at the figures or whatever they're given, and say, oh, well, we've been given here the radius. So now I guess we're going to substitute that in, right? So let's go find. And the next line is the same equation, although this time I've substituted right here the radius from here, radius cubed to now 4 cubed. And really nothing else has changed, but we're going to simplify in the next step. The next step says the volume of a sphere. I have 256 divided by 3 pi. I left the pi in the answer. I didn't multiply by 3.14. This is much more accurate. If we want to take the approximation, you'll see it at the very bottom. It gets approximated. And it's right here where it says it's about this size. So we take this and we multiply it out. 4 cubed is 4 times 4 is 16 times 4 is 64. 64 times 4 is 256. Okay. And divided by 3 and times pi. So 256 divided by 3 times pi cubic centimeters. That's it. That is literally the answer. And as you see, it is exactly that answer. This next line, it shows that it's approximately 268.1 centimeters cubed. And that's because we took this pi right here and we multiplied 256, we divided it by 3, and we multiplied by 3.14. And that's how you get this answer here. Okay? Okay, so in this next problem, on example 2, they want us to find the radius of the sphere. So we're not given the radius. What are we given, though? If you look at the problem picture, we're given the volume. And you pretty much need the volume and the radius, and you can solve for anything in a sphere, right? There's only 2 things to look for. So again, we start by, writing down what we know. The given area right here at the very top is the volume of the sphere is 288 pi inches cubed. As you see, it's over here. Where did my pencil go? I think I lost it. Oh, there it is. 288 pi inches cubed. Then I wrote down the formula. I like to always write down the formula. We're working with 4/3 pi r cubed. Okay. So what can I put in? I can put the volume of the sphere in for the volume right here, where the v sub s is. So now I have 288 pi inches cubed is equal to 4 pi divided by 3 times the radius cubed. And we're trying to solve for the radius. They want us to solve for the radius. Okay, so we're going to get the radius by itself. And the way you do that is what? We have 288 pi inches cubed. We're going to multiply both sides by the inverse, right? By the reciprocal of 4 pi thirds. We're going to multiply both sides by 3 over 4 pi. We just flip the fraction upside down. We multiply both sides by, where'd the pencil go? There it is. By 3 over 4 pi. Let me change the color, make it a little obvious. 3 over here and here. We'll multiply both sides by that to get rid of this piece right here. And by getting rid of it, I mean we get and set the radius by itself on this side of the equation. So we do that. So now when we multiply 288 pi inches cubed by 3 and divide by 4 pi, we end up with 216 inches cubed. And that's equal to r cubed. And we want r. So what do we have to do? We have to take the cube root of both sides. Well, if you do that on your calculator, you just say cube root of 216 and you end up with 6 inches. The radius of this sphere is 6 inches. Okay, exercise A. I have it written down here. This is on your own. They want you to solve these. And then when you come back, you're going to stop the video, hopefully. And then when we come back, we'll do them together. So I'll read the instructions. It says, find the volume V or the radius R of the sphere. We have 2 different balls here. Round your answer to the nearest tenth, if necessary. So if it's hard to read, it's 16 feet across the one sphere, and the other one you're looking for R. The one that you're looking for the radius is 36 pi meters cubed, it says. So go from there. When you come back, we'll move on and try them together. Okay, now that you've had time to do these, let's look at them and see what we come up with. So for number 1, we have, again, volume of the sphere right here. Volume of the sphere. This is writing the equation. Volume of a sphere is 4/3 pi r cubed. Okay, and then before we get started, we should look and find out what's been given. Well, 16-foot diameter has been given, so we know that the radius right now is equal to what? 8 feet. Okay, the radius is 8 feet. So we're looking for V. We don't know the volume. So when we come down here on the second line, we're going to now substitute what we know into the equation. Gets us rolling in the right direction. So here we say the volume of the sphere is equal to 4/3 pi times 8 cubed. You substitute the 8 for the r. And when we do that, and you do the math, 8 cubed, you cube 8, and then you multiply it by 4 and divide by 3, you're going to get 2,048 divided by 3. No one says you have to do that division. Leave it just like that. It's nice integer numbers. They're easy to handle. And that's a legal answer right there. And it's times pi, especially since you're leaving pi as pi, which we normally want to write 3.14159, whatever. Since we're leaving pi as symbolically itself, we don't have to divide by the 3 and get some fractional answer, so to speak. Anyways, when you do this, you're going to end up, and then eventually you'll multiply by pi, but when you do this, you're going to get a volume of the sphere of 2144.7 feet cubed. And as you see here, it's about 2144.7. And as we've talked about it before, why is it about? Because the moment you take and convert this pi right here to any decimal equivalent, and I don't care how many decimal digits you have, It's always going to be an approximation because pi goes forever. It's hard to think of, but think about it. Pi never stops. Okay, so there it is. It's an approximate. Therefore, we say it's about 2144.7. It is exactly 2048 divided by 3 times pi feet cubed. Exactly that answer. Okay, on the next one. So now we're going to do the same thing. We're going to write down the equation. We always like to write the equation. And when we do that, we know that we have the volume. Oh, we're going to substitute the volume, which is 36 pi meters cubed. So I've got substituted 36 pi meters cubed. And that is equal to 4/3 pi r cubed. Well, we're looking for r, so we're going to be trying to separate r by itself. Okay? Like we did in the previous problem. So 36 pi meters cubed. How do we get the r cubed by itself right here? We have to multiply both sides of the equation by the reciprocal of this number right here. Well, this number 4/3 pi, 4/3 times pi, is the same as writing, I'll write it up here, is 4 pi thirds. You can put the pi up with it like that. And then when you turn it over and you flip it over, it ends up being 3/4 pi. You just flip the whole fraction over. Okay? Not to confuse, because you have to take the pi with it. You can't leave the pi out here and then not flip it. So I put it up above the fraction bar. Anyway, so here it is. 3/4 over 3/4 pi multiplied on both sides. 3/4. That cancels this 4 pi over 3 on this side and leaves us with the r cubed. And on the other side, it gives us 36 pi meters cubed times 3 divided by 4 pi. Well, that comes out with a really nice straightforward number, because when you do that, the pi's cancel, and 4 goes into 36, 9, and 9 times 3 is 27 meters cubed. That's the radius cubed. They want to know the radius, so we have to take the cube root. So we have to get the cubed root of 27. Okay, and if you calculate that, if you can do it in your head, that's wonderful. If not, do it on your calculator. You're going to find that it's 3 meters. R is 3. 3 times 3 times 3 is 27. 3 times 3 is 9, times 3 is 27. The radius is exactly 3 meters. Why is it now, well, all of a sudden did this become exactly 3 meters? What did we do differently? Well, what we did differently is we never had to multiply by 3.14 anywhere. Up here in the equation, there was a pi right here, and there was a pi down here in the denominator of this little fraction, 3/4 pi. They canceled. They're gone. So there's no reason to multiply by a decimal number. So now this is the exact answer. The radius is 3 meters. Okay, in example 3, finding the volume of a composite solid. I left it blank. I have the next slide has the solution to it, but I wanted to look at this as it is before we start writing numbers on the screen, just to observe and what we're looking at. So, because this is a composite solid, and what is a composite solid? Well, in our case here, we're going to say here that a hemisphere is 1/2 of a sphere, right? So if you have this ball, whatever the ball looks like, if you cut it in half of it is called a hemisphere. Okay? So the top of this silo, as you can see, is half a ball. Just so they're seeing the big picture of it, it's a hemisphere right there. It's half of the ball. You could take the other half of the ball and use it somewhere else if you had to, or make another silo with the other half of the ball. And then on top of that, that's the top of this. It has a hemisphere, and the radius is 12 feet. They tell us right here that the radius is 12 feet. So now we know everything we need to know about that sphere or hemisphere. And then they want to know, what is the volume of the silo? Well, what is the volume of the silo? We know they tell us how tall the entire silo is. They say it's 52 feet. And we know that the that the hemisphere, or the sphere itself, has a radius of 12 feet. So that means if you take it and spin it around up here, the 12 feet from here to here, you're going to add 12. You're going to subtract 12 feet to get this number here. So you have 52 minus 12, and that leaves you with 40 feet right here. So for the cylinder, so this is a two-piece item, right? A hemisphere and a cylinder. And the cylinder has a diameter of 12 feet. It's the same as the sphere. As this hemisphere. 12 feet radius. Now, I said diameter, excuse me. The radius is 12 feet and a 40 feet high. So now that's the picture. And what they want you to do is, it says here that the silo is made up of a hemisphere and a cylinder. Find the volume of each, and we'll add it together too, okay? It says, what is the volume of the silo? And they want you to round your answer to the nearest thousandth. Well, we'll see how that turned out. Okay, so now we're going to move on to the next slide, which has the solution. Okay, so now that we're here, we can look at this and see that we've started with as usual, with the equation. And what is the equation? The equation here is the volume of a hemisphere is 1/2 of the volume of a sphere, and the volume of a sphere is 4 pi over 3 times the radius cubed. It's 1/2 that value. So we also looked and saw what's the given. We have a given radius of 12 and a given overall height of 52 feet, and a given here, it says that the height of the cylinder for the silo is 40 feet. We have everything we need to solve this problem. So when we go to substitute here in the second time here, we're going to substitute 12 for the radius. Here's where we're substituting 12, right here, the 12 feet as the radius. And when we do that, we're going to get, in the next equation down here, we're going to get 1/2, 4 pi over 3 times 1728. That's 12 cubed, 1728. And if we simplify this, and we multiply 4 times 1728 and divide it by 3, and then divide it again by 2, or multiply by 1/2, however you want to think of it, you're going to end up with and pi is still in there, but we're just multiplying out the integer values, not the pi itself. We're going to end up with an answer of 1152 pi. That's the volume of our sphere. Okay, and that's going to be, what we're in feet, so this is going to be in feet cubed. Feet cubed. Excuse me. So now for the volume of a cylinder. So that's pi r squared times the height. We know the height, and we know what the radius is. So that's our formula. So in the next equation, we're going to substitute 12 for the radius, like we did up here, 12 for the radius. Only this time it's squared. And the height of the cylinder is 52, the total height right here, minus the radius of this hemisphere right here, this distance from here to here, the radius, 12. So we end up with 40. So now in this equation, we're going to say the volume of the cylinder is pi times 12 squared, 144, times 40. So here it is, pi times 144 times 40. And the answer there is 5760 pi. And guess what? It's going to be feet cubed. So now we put them all together. So the volume of the silo is 5760 pi plus 1152 pi, and that's going to give us 6912 pi. 6912 times pi. That's the exact answer, because pi is still in the answer right here. Pi is still in there. Okay, so when we substitute pi for 3.14, we're going to come up with 22,000 cubic feet. So our answer is 22,000 cubic feet. Okay, exercises B on your own. Directions: find the volume of the composite solid. Round your answer to the nearest tenth. So as you know, these are for you to do. And it's the last slide in this section, so that'll be nice. We'll get this over with and move on to another video. So go ahead and think about this. And when you come back after trying them, then we'll do them together. But let's start off by talking about what's the given. Excuse me, I'm sorry for that. What's given is that the overall length of this particular solid right here looks like some kind of a capsule, a pill of some type, or maybe a propane tank out in the yard, right? That's kind of the way a propane tank looks. Anyways, it's 8 inches long, and it's 2 inches. The radius is 2 inches. So we know everything we need to know. This is a double hemisphere, 2-inch radius, 8 inches long. For the other problem, we have a 3-meter radius, 3-meter radius, right here, okay? And we have a cone height of 5 meters and a cylinder height of 9 meters. Okay, with that, you should be able to go and solve these. When you come back, we'll do them together. Okay, so now that you've had some time to do these, it looks like 4 problems we have to work here, because the problem 3 has 2 pieces, problem 4 has 2 pieces. Excuse me, what does it say? It says find the volume of the composite solid and round your answer to the nearest tenths. And so on 3 here, I said, we'll use both halves of the sphere in the solution of this problem, right? Because this is like a ball cut in half on one side and a ball on the other side. So it's 2 hemispheres, which makes up an entire sphere. So we're going to solve for a sphere. I'm not going to solve for a half a sphere or a hemisphere and then multiply by 2. Kind of doesn't make sense. We can always look at what we're trying to solve and make the problem easier. So we're going to solve for a sphere and a cylinder. So the sphere is right here. The equation formula, the volume of the sphere is 4 pi over 3 times the radius cubed. Okay? We know what we looked at our factors is what we can substitute, what's given. We know that what's given us is the radius, and it's 2 inches. Right here it's 2 inches. Okay? So here 2 cubed. Taking it a step further, the volume of the sphere is 4 pi over 3 times 8, because 2 cubed is 8. And simplifying at this point and leaving pi in the answer to give us an exact answer, 8 times 4, 32, divided by 3. We're not going to change it. Times pi. That's it. The volume of the sphere is 32 pi over 3 inches cubed. That's the volume of the sphere. That's the end pieces added together. So now we're going to find the cylinder. The volume of the cylinder right here is pi r squared times the height. So rewriting this now and filling in the givens, or what we know that the radius is 2, and we know that the height says 8 inches for the entire solid, but we have a sphere that takes up 2 radii, and the 2 radii are 2 inches each. So there's 4. So it's 8 minus 4, and that leaves us with 4. So, and 2 squared is 4. So now in this equation, the volume of the cylinder is pi times 4 times 4. The volume of the cylinder is 16 pi, again leaving pi in the answer, inches cubed. The exact answer, 16 pi inches cubed. Or we can write it, the volume of the cylinder is 48 pi over 3 inches cubed. Well, why did I do that? Why did I just change the way it looks? It just changed the way, I just changed the format of this fraction. And what we have, the reason why, is because the volume of the sphere is divided by 3. So we want to add these together. We have to add the values of the cylinder and the sphere. So we get 32 pi over 3 and 48 pi over 3. And when we add 32 and 48, we get 80 pi over 3 inches cubed. Now we can do an approximation if you want to. We can take 80 and multiply it times 3.14, and then divided by 3, and we'll come up with approximately, as it says, approximately 83.8 inches cubed. So that's that solid. Now let's do the next solid. Again, we look at the solid to see what's given. We know that the cone height is 5 meters. We know, I'm going to change my color here and make it a little more obvious. The cone height is 5 meters. The cone radius is 3 meters. And the radius of the cone is also the radius of the cylinder. And the length of the cylinder is 9 meters. That's our givens. So let's go back to our equation that we've written in here. And so the volume of a cylinder is pi r squared times the height. And then we start substituting our givens into that equation. We know that 3 is the radius of the cylinder. So the volume of the cylinder is pi times 3 squared times 9, or pi times 9 times 9, or, simplifying it, the volume of the cylinder is 81 pi meters, 81 pi meters cubed. Okay, my pen's going wacky on me for some reason. Okay, let me see if I can erase that, because I don't know why. Every once in a while, my pen has a little fit, and it does things that it shouldn't be doing. So, 81 pi meters cubed. So that's the cylinder. And the cone is 1/3. If you remember now, the cone is 1/3. A sphere was 4/3. A cone is 1/3. 1/3 pi r squared h. Okay? It's the same equation except for the 1/3 as we just completed, but the height is different. The height was 9 meters for the cylinder. The height is 5 meters for the cone. So when we substitute in here, we're going to get the volume of the cone is equal to 1/3 pi 3 squared times 5. And that is 1/3 pi times 9. 3 squared is 9 times 5. 1/3 pi times 45. We can simplify that very easily to the volume of the cone is 15 pi meters cubed, because 45 divided by 3 is 15. So now we can add these together. So the volume total is 81 pi meters cubed right here, plus 15 pi meters cubed right here. We can add them because the pi isn't, it's all legal to add these as we're doing. And when you add 81 and 15, you get 96 pi meters cubed. And or you get approximately, because we're getting rid of the pi, so you multiply 96 times 3.14 and you'll get 301.6. Okay, there's our answer.